Good morning or good afternoon and welcome. My name's Sarah, your host for today's webinar. For your information, today's session is being recorded and will be made available through the Juniper Learning Academy. If you have any questions during the presentation, please type them in the Q&A pod by clicking on Q&A at the bottom of your screen, and we'll answer either during or after the presentation. So thank you very much for taking your time to attend this webinar today. And to start off, it's my pleasure to introduce your presenter, Mr. Eric Osberg. Thank you, Eric. The floor is yours.
Okay, thank you, Sarah. And everybody, thanks for joining. And as you know, this is like the first bootcamp part 1 we're doing today. And for those of you who have looked into the agenda, you know that there will be 2 other bootcamp sessions coming up. We have today, which is like we call DC Fundamentals. So it's me and my colleague Mutu. We will share with you some of the DC architectures, and then also looking in telemetry, and also to some extent how to quote the Paragon portfolio, which is related to data center. And then on Thursday, that in 2 days, we have like a whole session then for Abstra. So we'll be very much focused on Abstra. And then last but not least, next week on Tuesday, we do DC security together with automation. And automation in this sense is very much for those who do not want to do Abstra, but rather do like controllerless data center using Ansible and so forth. And the idea behind these sessions is, as you might have understood, is very much around Abstra. So with the session, we try to cover things which are related to Abstra, either directly or indirectly. So what we're trying here to do is, like in the center, we do have Abstra, which we believe will be a vital part moving forward for all data centers with Juniper, and of course with other vendors, as you know, as we support Cisco and Abstra and others. Arista should be. But then around Abstra, as you know, there are other things, solutions that you could add. So of course, today we will focus a little bit on QFXs, or actually the hardware that you could support by Abstra, and also controllers. And then, of course, also telemetry. So Paragon, the Paragon portfolio, in this case, we're looking into insights and assurance, how that could be incorporated into data center environment. And then on Thursday, we do more on Abstra in general. And last week, as I said, security, and then controllerless, which is mostly around Ansible and how we can use Nita. Grayed out here, for those who have been around, we have had, and we still have Contrail, but Contrail has slightly been, how you say, updated in that sense. We have moved away the focus, so that was be not part of these sessions, maybe future sessions based on your feedback, but of course, Contrail could be a part of this as well. And from our side, what we would like to hand over to you is, like, not only given these presentations and slides, of course, we are trying to do this, cover all these processes which is involved, like a sales process. So after doing this bootcamp, you should be able, at least on a high level, to do all these 4 things mentioned in the middle of the slide. Is discover, propose, demo, and quote. As you understand, in data centers, it's quite complex, so we cannot cover everything in total 6 hours, but that's the intention. So please bear that in mind. And for today, before I hand over to my colleague Mutu, I just want to give you the agenda. So we have like 2 sessions today, I would say. So Mutu will start off with DC fundamentals and switching portfolio. And then in the middle, we do appreciate it's a long session, so we will have a short break, 5 minutes, and before I will then start discussing telemetry, and more specifically how that is used in data center together with Paragon Insights and Paragon Active Assurance. So with that, I would like to hand over to my colleague Mutu. Mutu, are you ready?
Hey, Eric, that was wonderful. Yes. So I'm just going to
great.
Share my screen and get it going.
Perfect.
Is everything looking good?
Looks good.
Okay, wonderful. So I welcome you all again for this webinar, and in the next, let's say 45 to 50 minutes, I want to walk you through the different DC design options that we're actively considering in Juniper. We'll look at some EVP and VXLAN fabric options and some data center interconnect options. So when I mean we are going to look at the DC architectures that will obviously be aligned to our strategy, what we have with Apstra as an fabric manager. And what we see today in what customers are building is actually, they are either building an IP fabric or an EVPN VXLAN based fabric. So the main difference is like where the overlay actually sits, right? In an IP fabric, the overlay sits in the host. Like we're talking about solutions like Contrail or Cisco ACI, VMware, NSXT, or the hyperscalers, they build their own solutions. So you have a layer of hosts here, and that terminates the VXLAN, EVPN, all the VTEBs, what you have. That essentially has a very simple IP fabric. You're not doing too many stuff there. But we also see customers who, on the right side, you see they build an EVPN VXLAN fabric where you have the leaf, spines, and super spines, and they put EVPN and VXLAN on top of that. Or what we also see is customers doing migrations, which is quite an interesting use case where they initially start off with an pure IP fabric with host-based overlays, but they still want to move to an EVP and VXLAN fabric. That brings in new challenges because you already have VTEBs and control plane on the host, and how do you then move it onto an EVP and VXLAN fabric? So these are pretty much where the architectures are going that we currently see in the industry in a broader sense. So before we even move to these fundamental things, right, I just want to highlight the advantages of moving to an IP-based fabric. So back in those days, we still had layer 2, right? We deployed proprietary solutions, which was limited in scale. Then we move to some chassis-based solutions, right? Like we did QFabric, VCF, Drill, which was, even though some were standardized, some were proprietary solutions, and which led to vendor lock-in. And the focus was really on a box kind of a solution. We expected, we deployed bigger boxes, and then doing a maintenance on those boxes were a bit challenging. We needed features like NSSU, ISSU to do software upgrades, but it's still maintaining that graphic, and that did increase the complexity of the boxes. But now, the whole industry has moved on, to the IP fabric, which is more built on open standards. Like you're building fabrics with BGP and EVPN, and which is no longer proprietary technologies. And the most important thing is we are now moving to a more disaggregated architecture where the networking gears are actually scaled out, right? So we are not deploying bigger boxes, but you deploy one rack unit kind of boxes and build your fabric based on that. So what this idea has gotten to is like, components can actually fail and recover quickly with little or very marginal disruption to your network, right? We are no longer worried about that, a single box blows up and stuff like that. But even if a spine goes down or if a leaf goes down, yeah, for that point of time, you lose certain redundancy and bandwidth capacity. But with a lot of ECMP paths available in your fabric, the disruptions is pretty less. But the challenge with this new IP fabric is like, the number of boxes have increased in this disaggregation mode, and then you have more devices to manage. And that's exactly where, solutions like Apstra come in, which brings in more value in managing the entire fabric, which Eric is going to talk in depth in the coming sessions as well. So we in Juniper, when we talk about the main building blocks of an EVPN VXLAN based fabric, it boils down to point numbers 1, 2, and 3. So you have an infrastructure which has an underlay, which is eBGP based, and a network infrastructure overlay, which is also eBGP based, and VXLAN tunnels, as you see here, where the VTEPs could reside on the hardware, on the leaves and spines, so leaf to leaf or leaf to spine, or the VTEPs could reside on the server, so you can have an VXLAN between a server and to a leaf or to a spine, depending on your architecture, right? So before we even discuss in detail about all these things, right, there are still questions asked like, why BGP? Why not OSPF or ISIS? And that's the fundamental question that we want to ask. I mean, BGP supports multiple address families, right? It's really flexible. It supports v4, v6, EVPN. You can do VPN v4, and it's comes with a rich set of routing policies, communities and stuff like that. It's internet scale. It works. The whole internet works with eBGP. We have understood that pretty well, and BGP has also been extended. I mean, especially if you talk about the configuration perspective, we have features like BGP unnumbered, where you use IPv6 link local addresses to establish your BGP sessions, right? So you no longer need to configure interface IP addresses, for example. So that's a big difference when it comes to automation, or even if you configure things manually. Or when it comes to configuring your BGP neighbors, today you can even use your interface names instead of your neighbor IP addresses, right? And configuring BGP neighbors, you don't, there are features where even your autonomous system numbers could be discovered during your BGP session establishment time. So you don't have to specify that remote AS number in your config anymore. So BGP is being continuously improved, and it makes the life of deploying those BGP deployments in the data center network quite easy. And I can refer you to this RFC, the 7938, where it discusses about deploying BGP on a large scale data center network. I mean, even though it's written here as a large scale data center, even smaller data centers, they have their benefits of running BGP, right? So the next question that we want to answer is like, why eBGP, right? I mean, you have iBGP as well. eBGP scales really well. iBGP really needs a full mesh. Of course, you have route reflectors and configurations to mitigate that. But then you want to manage those route reflectors. eBGP scales naturally well in that perspective. And also eBGP is better at handling routing loops because it natively has this AS path, and as opposed to iBGP, which relies on the route reflectors for doing that. And eBGP satisfies the external router DCI use case, right? When you want to interconnect your DCI to the external world, you're anyway having eBGP there. So with eBGP, you have one protocol running in your overlay, one protocol in the underlay, and one connecting to the DCI, and that makes your configuration, troubleshooting, and you can quickly come to your root cause analysis quickly. So this also aligns pretty well to the Apstra strategy that Eric is going to talk in the future, where Juniper is pushing eBGP overlay, underlay, and for the DCI interconnects as well. And some of the challenges that customers have faced, or concerns that customers had with BGP was, in terms of conversion. They, in a service provider network, right? BGP typically holds off sending BGP notifications about changes for a while, right? But inside a DC, you don't want that to happen, right? You want that quick routing convergence. So what, if you go through this RFC 7938, They talk about all these timer optimizations. There are some knobs in BGP which you can fine tune, like this minimum route advertisement interval timer, keep alive and hold timers, connect timers, which normally in a given service provider environment, you normally don't tune those things. But when you go and build a data center with BGP, you might have to, it makes sense to turn on these knobs. And one of the other concern with using BGP was, with this path hunting challenge that they had, but with intelligent allocation of the autonomous system numbers and, with these timers and intelligently controlling the prefix advertisements within your pods, you can overcome these challenges as well. And as I pointed you earlier, like with simplified IP unnumbered configurations and especially with exciting tools like Abstra, you can simplify your configuration part of the story as well. People were concerned, like, OSPF is pretty easy to turn on. The number of lines of configuration changes that is needed to deploy OSPF is less when compared to BGP, but that's not the problem anymore. As I told you before, we have this unnumbered IPv4 interfaces. You could do that, and Abstra takes away exactly this complexity away from the operators, right? From smaller DC environments where people have less experience with BGP, right? Abstra is a multi-vendor environment, and if you want to fine-tune all these BGP parameters, Abstra does it at the underground this for you, right? So you don't have to know what knob should I turn in Arista or Cisco or Juniper so that BGP is optimized. So we have aligned our DC design strategy. That's what you're also going to hear in the next 40 minutes from me. The designs that we are going to show or see today are perfectly aligned with the Abstra solution as well. So broadly inside Juniper, we are talking about, especially when it comes to overlay, we see 4 different models. One is a bridge overlay model, which is mostly used by some kind of a secure environment where you have your layer 2 gateways at the leaves, and basically your spine does not, in your leaves and spines, there's no IRB, that you're not doing any layer 3 terminations. The layer 3 termination is typically external to your fabric. What your fabric does is a pure layer 2 transport, right? So this is one of the use cases that people have been using. The second option, what you have seen is the CRB model. It's a centrally routed bridging model where you put the layer 2 gateways at the leaves and the layer 3 gateways at the spines. That means you put the VTEPs at the spines. So that's been one of those models where, where you had the traffic more going north-south. It made sense to put those VTEPs on the spines, and then you interconnect your external DCIs from the spines directly. And the ERB model, or the edge routed and bridging model, ERB is the model that we'll be focusing more today, and that's also a model that's aligning with our Arista strategy, where the spines are becoming more lean here. So it's doing only a plain IP routing here, and your layer 2 and layer 3, your VTEPs are terminated only on the leaf, server leaves, and on the border leaf, right? And the border leaves connect to the external world. And then for smaller data centers, we can offer a collapse spine where, a single layer, right? It does the role of, we have integrated the function of a border leaf, a leaf, and a spine all put together and interconnected. And you might have on top of rack switch and then virtual chassis mode, and then you can interconnect that within a collapse fabric. Quite interesting for smaller deployments. So as I told you before, Juniper is standardizing on ERB going forward. So mainly is driven by customer adoption, right? The silicons and hardwares have changed now. We have more the Trident 3, Trident 4 kind of chipsets, and with a lot of features, EVPN features. The leaves are now able to have more intelligence, do a lot of routing and switching capabilities. and mostly the cost of these ERB-capable leaf switches are also dropping. So as we see the industry, more customers are moving or adopting this ERB model, and that's why inside Juniper we are also aligned to this ERB strategy. And Eric is going to talk about how this is handled in Abstra as well. So what happens in an ERB model is, your spine becomes a lean spine, right? It just does in plain IP routing. There are no VTAP terminations there, so there's no VXLAN NCAP or DCAP happening there. So that allows you to put a simpler ASIC there, right? And there are no service instantiations like VRFs or routing instance configured. So that makes these configuration of the spine quite simple. Combine this with this IP unnumbered interface configuration and other features that BGP has. If you look at the spine configuration, right, it can be really, really simple. And the whole device, the whole routing that happens in the spine, all it does is plain IP routing and nothing else. Right? And then doing a device maintenance also becomes easy. For example, if you want to drain traffic from a spine, you can, because it's all BGP based, you can drain traffic. So the BGP will advertise to the neighboring devices that's, don't send me any traffic, and then you can drain traffic, and then you can gracefully upgrade the spine, right? And you might probably start off with a 2-spine network, and then you might add additional spine layers here. If you clearly demarcate the spine on the border leaf node, this kind of migration, when you do in the future, that would be really easy. Instead, if you put your spines and connect your external DCI interfaces directly on the spines, and then at a later point of time, you want to add more spines, and doing that kind of maintenance also makes it a little bit more complex, right? So essentially what happens is, right, the inside the DC, it kind of resembles a service provider network. You can think of the leaves as your PE routers and the spine as a P router, very simple, and your intelligence is moved to the leaf and the border leaf nodes, right? And then you also reduce your ARP progression, right? When you do the ARP suppression, right? It's confined at the leaf layer now. Your ARP requests and the flooding, the bump traffic is never flooded to the spines now, right? So these are some of the advantages of to an ERB design. So let's take a slightly deeper look into this ERB design that's interesting. So here you see the server layer. The servers are dual home to the leaf nodes, and the leaf nodes are connected to the spines. Spines are connected to the border leaf, right? And the leaf nodes have your layer 2 VNIs and layer 3 VNIs configured as VRFs, and the border leaves have the same elements, right? The layer 2, layer 3 VRFs, and the border leaves are connecting to your external appliances. So typically in the underlay, you run eBGP, and you basically advertise your loopback IPs, and you use your interface IPs for that. And then your overlay, you're doing your eBGP as well, doing eVPN signaling, right? And for your overlay eBGP sessions, you'll be using your loopback IPs. And over that eBGP session, you'll be advertising your different route types, right? In eVPN world, we have this route type 2 for advertising your MAC and IP advertisements, and route type 5 for your prefix advertisements, and for bump traffic. To facilitate the bump traffic, you use the route type 3, and we do ingress replication. That means that you don't enable any PIM or DVM RP or kind of multicast protocols in your fabric, right? You don't need that. You can do it with ingress replication, and then you have your route types 4 and route type 1s, especially when you're doing the ESI active multi-homing. So here you see the server, it's doing active multi-homing. It's in an ESI lag, and that is achieved by using the route type 4 and route type 1. So this is the kind of signaling that happens on the eVPN. And coming back to the external connectivity, you see here, you could connect external devices. The external appliance could be an L3 capable. That means here you have an option to do BGP, or you can do a static routing, for example, or your external appliance could be only a layer 2 device, could be in firewall, for example. And what you can do is you can do an ESA lag here, because ESA lag is in layer 2, right? From the perspective of the external device, you're just doing an lag, and you're the VXLANs are terminated on the border leaf. Or your external appliance could be VXLAN aware, for example. There are products there that are, firewalls, or some products are coming with this feature where you can extend your VXLAN tunnels and EVPN control plane all the way to your external appliance. In that case, then Juniper offers you a lot of possibilities. For example, you can peer with the VRFs, right? Or you have your INET.0 table, and then you can do peering from that. Juniper offers a lot of flexibility, like, you can leak routes from your INET 0 into the different routing instances or VRFs, or you can use construct like RIB groups and so on, and write policies to import and export prefixes. So Junos is really flexible. It makes a real difference in this case, because depending on the capabilities of your external appliances, you can flexibly configure your border leaf solutions there. And as I discussed before, there are some federal customers, government customers, and they push the layer 3 interface all the way to the external appliances, and they just want a layer 2 function from the fabric. So in that case, an L2 bridge overlay could be an option, where you just create your layer 2 VNIs on the leaf, on the border leaf, and you're just doing layer 2 within your fabric, and your the gateway function is actually external to the fabric. So this is more seen, for security purposes and for stateful inspections and those kind of applications. The L2 bridged overlay is a supported option. And what about smaller networks, right? I mean, in a smaller networks, customers may be concerned, okay, why should I add another border leaf kind of layer? Is that a way that I can still use the ERB model, but kind of collapse certain functions? Yes, we can do that. You can collapse your server leaf and the border leaf into a box like this, right? So this is a standard server leaf, right? Servers are connected in an ESA lag fashion, connecting to the spine. And then you have this collapsed server and border leaf here, which is highlighted in the green color, where you can connect your servers in ESA lag and then like a normal server leaf, but you can also connect your external devices there, right? So you're still conforming to the ERB design, but you are avoiding an explicit border leaf rule here. But in principle, the way you configure this box, the solution or the way routing works is exactly the same if you do an explicit border role function. So this can be quite interesting for customers who are, a little bit concerned about the price. They don't want to invest in a separate border role. But you can still have the advantage, right? You're still making the spine more lean, and you can, depending on the future need, you can grow your spines independently. You have all those advantages as well, right? And then a collapsed fabric solution, as I mentioned before, is also ideal for smaller use cases where the role of the border leaf, the spine, and the leaves are all collapsed into a single layer. And you put your L2, L3 VNIs, your VRFs, or external peering all at this layer. And you need to interconnect them, of course. And if your existing top of rack does not support EVPN, then you can just connect them using an ESI lag, active multi-homing. So this can be very interesting for smaller deployments or very small data centers. And you can fully connect in the same way, what have you. Your external appliances could be L3, L2, or it can be EVPN aware as well. So everything is supported here. So let's move on to the data center interconnect part, because now we discussed certain strategies about what you can do within a DC, but customers have multiple data centers. Excuse me. Typically, what we see is customers eventually land into one of these possibilities. They might have an IP backbone, or they might have an MPLS backbone, and some of their requirements, maybe customers, they might require a layer 3 DCI only. Some of the customers might want to stretch their layer 2 and layer 3 into the other DC, right? So you fall into one of these 4 categories. If you're doing a layer 3 only DCI, and if you have an IP backbone, then you're working with EVPN type 5 and VXLAN, where you're extending your EVPN control plane to the remote data center and you're using VXLAN. But you don't have to do that if you're having an MPLS backbone. You don't have to extend your EVPN control plane all the way to the remote DC. Instead, you can hand off to the IPVPN and still use the MPLS as your data plane. So you're kind of splitting your domains into inside your DC. It's going to be EVPN and VXLAN, and in the MPLS backbone, you're relying on the IPVPN MPLS, which is predominantly seen today, right? And then if you want to stretch layer 2 and layer 3 across DCs, right, and then you need to extend your EVPN control plane across to the remote DC, then you have to extend your type 2 routes as well, apart from the EVPN type 5s. And then you have this over-the-top solution for that. But once you extend your EVPN from one DC to another DC, then depending on the size of the data center, sometimes you have to do the full mesh of VTEPs. That could lead to some scalability concerns. Then you have to think of technologies like, can I do some kind of seamless stitching between and so on, which I will discuss in the next sections. The other option is if you have an MPLS backbone, especially if you're having an MX device as your DCI, what you could do is you can hand off the VXLAN, the layer 2 to an VPLS instance, and your layer 3 part to an IPVPN MPLS instance, or you can stretch your, you can do the stitching between EVPN to an EVPN MPLS. I'll be discussing this in one of these next slides, right? So you have different options to do this DCI part depending on what kind of backbone that is currently available. So when it comes to DCI, so this slide shows where you're doing a DCI, you're interconnecting 2 data centers. Let's say this is data center 1 and data center 2, but you're having an MPLS backbone, and the only requirement is you're going to do an L3 DCI. So what happens is on these gateway devices, right? So here you see that it's shown as a spine layer, but you can also do the similar thing on border leaf as well. But the fundamental idea is you're doing an IPVPN peering between these border gateways, right? And you're exchanging IPVPN routes across your MPLS backbone. So your EVPN control plane remains within your DC, right? So all your route type 2, type 5 advertisements are confined within the DC on either side. So you run your EVPN control plane, right? And also your VXLAN, everything is confined within the DC, but those routes are advertised as IPVPN routes via the backbone, right? So you're doing IPVPN with MPLS backbones, right? So that's what happens. So the key function here is actually, as I told you, the stitching between the EVPN, VXLAN termination, and then reorigination of these routes as IPVPN routes. And to be able to do this today, we need an Juniper MX, but we also are targeting PTX in 2022 to have that feature there. And if you're doing a layer 3 DCI, and if you have an IP backbone, right, you can natively extend your EVPN control plane all the way to the DC. That means like you can do an EVPN type 5 advertisements across the IP backbone. So how does it work? In this case, you're doing an EVPN peering between the border gateway. That means the spines, in this case, you run an eBGP session between those border devices, and you run EVPN address family, and then you start advertising your EVPN type 5 routes. So why type 5? Because you're doing only layer 3, right? You're just advertising your IP prefixes. You're not advertising your MAC addresses and stuff like that. So you can see here um, the blue VLAN and the green VLAN, right? They're all in a different IP domain, and the only thing you're doing, necessity is just to advertise your IP prefixes where you're not extending your layer 2. If you want to extend layer 2, right? So this is the case where you have in layer 2, where you're extending your layer 2 and layer 3 across an IP backbone. So in this case, what happens is, again, you're doing an EVPN peering between the border gateway devices. But in this case, you need a full mesh of VTEP peering. That's where the complexity comes in. Once you start thinking about extending your layer 2, it's not so simple as extending as opposed to just doing a layer 3 DCI, right? And you'll be advertising your type 5 and type 2 routes over the IP backbone fabric. So what is expected from this IP backbone fabric? The IP backbone itself doesn't have to support VXLAN because it's just doing an IP routing, right? The only thing that you need to make sure is the underlay session, right? You should be able to establish those eBGP peering between the L3 VXLAN gateways. That's the only requirement. You probably need to advertise your loopbacks across this IP backbone and make sure that they are reachable, right? The VXLAN routing itself is happening, those terminations and stuff like that are happening on the border devices within your DC. So let's take a little bit deeper look into what options do we have when it comes to layer 2, when you want to extend layer 2 across DCIs. The first option is called the the decoupled interconnect model. So what we mean by the decoupled interconnect model is you split your DC. Let's say this is your data center 1 and this is your data center 2. Right inside your data center, you have your leaf and spine, and you're having an EVPN VXLAN domain here, and you terminate your EVPN VXLAN on the spine, and then you do a normal layer 2 handoff, right? And with layer 2 handoff, of course, comes with MAC flooding and stuff like that. So that's your demarcation point. And your DC gateway then can have its own EVPN VXLAN domain. It could be EVPN VXLAN or EVPN MPLS, depending on what kind of core you have. And again, on the DC2, you again do a handoff to layer 2, and then you have an EVPN. So you're splitting your EVPN VXLAN domain, but in between you have this L2 handoff. I mean, this is harder to manage, right? I mean, it's traditional demarcation points. You could do this, but you have to deal with all these flooding and MAC learning, right? And then you go to this OTT option, which is the option 2, which is very simple, where you're not splitting your EVPN VXLAN domains. You just have a single EVPN VXLAN domain extending from data center 1 to data center 2, right, across an IP fabric. Yeah, it looks simple, right? But it has some scalability concerns. I mean, if you have a smaller DC, if you want to keep simple, right, you can do this OTT. But once you start extending a lot of layer 2 into the other DC, and as the network grows, then you easily run into scalability issues. And you have lack of clear demarcation points, right? Especially when your organization has different administrative domains, then this could get a little bit complex to manage. So the recommended solution for DCI is the unified or seamless EVPN VXLAN stitching solution, right? So what we are doing with this solution is, we are configuring the spine devices, or it could be a border leaf, this ERB design, right? We call them as the interconnect gateway, and we are actually splitting the EVPN domains into different components and then stitching them at these interconnect gateways, right? So There could be like, that gives you a lot of flexibility. You could have multiple tunnels, VXLAN tunnels, which you could map onto a single VXLAN tunnels that's goes across the spine. You could selectively extend your layer 2 domain. So there's a lot of flexibility when we do this seamless EVP and VXLAN stitching, which I would talk about in a little bit detail in the subsequent slides, right? And this is one of the proposed, or let's say, recommended designs when it comes to DCI. So this is the problem that I told you before when you are have to deal with the full mesh of VXLAN tunnels. When you extend your pods or extend your DCs, then you have to configure a lot and getting analytics and to figure out what's going on, because it's a full mesh of VXLAN tunnels between the pods. Instead of doing a full mesh, the seamless multi-pod EVP and VXLAN, it actually splits your VXLAN domains into 2 parts, right? So within your pod, you have these green VXLAN tunnels, right? That's confined within your DC. And your interconnect gateway here, you see that, right? It could be on a spine or it could be on a border leaf. Then you can map, and flexibly with some policies, you can map those internal EVP and VXLANs onto these kind of interconnect VXLAN tunnels. And then, for example, when you're adding a new pod or extending your network, then you just need to extend, this pod alone. Easier to add a new DC pod, and it's more manageable, and less flooding. It gives you a lot more options to managing your DCI fabric as it expands. So this is a typical design where where we are using the seamless EVP and VXLAN stitching, and especially we are focusing on the border leaf function, right, where your interconnect gateway is on the border leaf. So let me explain you this topology in a little bit detail. So you have a regular DC where you have some compute resources here, right? They are doing ESI lag. They are dual home to a leaf layer here, and the leaf is connected to a lean spine layer, right? The spine, it's lean, right? We are following the ERB model. We're not doing too much on the spines here. And then you have the border leaf function, which is also your interconnect gateways, right? As you see here, right? And this interconnect gateway is actually connected to your IP core network. It could be an MPLS based, or it could be pure IP based, right? And then you have your remote data centers. So, right, so this is DC1 and this is DC2. So what happens typically in this architecture is, right, within your DC, right, you'll be having your EVPN type 2 advertisements and type 5 advertisements, right? They will be having their unique RDs, RTs, depending on, they'll be having their own ESI values, but all these advertisements, they land on the border leaf, right? And the border leaf, you see here, it's doing an eBGP session with the remote border leaf, right? And it's also doing EVPN here, right? So what happens is the EVPN type 2, which is nothing but your MAC and your /32 host IPs or your IP prefix, all these type 2 and type 5 advertisements that is originated by the leaf, right? They are terminated on the border leaf, and the border leaf, using this interconnect gateway, they re-originate the type 2 and type 5 advertisements, and they are sent across the IP core fabric to the remote border leaf. So in that process, you get a new set of IRD, interconnect RD, interconnect RT. So the RDs and RTs that this leaf originates, that is specific to what you have inside the DC. But the border leaf, right, it terminates, as I told you, because it's doing the stitching function. It re-originates these type 2 and type 5 prefixes with a new RD, RT values that you have configured here, right? With a new ESI value, IESI value, let's call it, right? And then it sends it across to the remote border leaf. And in this process, it also changes its next hop, right? So within when this leaf advertises an EVPN type 2 route, the next hop would be the leaf, right? But when the same MAC address is sent across the interconnect gateway, the next hop would be your border leaf, right? Or your what we call as the interconnect. So your next hop is changed, and then those advertisements are sent across your IP core to the remote border leaf, and then it gets propagated further. So that's how you extend your layer 2 and layer 3 into the remote DCI. So, and as I told you before, if you're doing a CRB, right, you can also use the spine layer. It's the same. It works. Everything works the same. But instead of using it on the border leaf, you're doing it at the spine layer, right? That's another option. And what you also have, right, when you with these DCA options, like you can have an multi-site DCI, right? You have DC1, DC2, and DC3 here in this picture, where you're using these border leaf functions in each of these DCs, and in this interconnect gateway role, and you're establishing a VXLAN tunnel. So in this case, DC1 is connected to DC2, and DC3 is having a VXLAN tunnel to DC2. So you can interconnect many DCIs in a multi-site DCA fashion as well, right? And last but not least, if you're using the MX and the PTX, it's coming in 2022, right? If you have an MPLS backbone, you can actually stitch your EVPN VXLAN from your data center. You can map your EVPN VXLAN into an LSP, MPLS LSP. You could be running RSVP or LDP or segment routing or what have you. You can map your EVPN VXLAN to an LSP, and you can stitch it here exactly on this gateway device. As I told you, this is an MX device, or it could be PTX next year, and you can do the reverse stuff here. So you have another level of flexibility. You can, if you want to have, if your backbone is MPLS enabled, you can do this as well. All right, so this is so far for topics related to DCs and DCIs, and now let's take a look at the product portfolio that Juniper offers, right? I guess there's a predominantly very good understanding of the DC portfolios, but broadly Juniper offers the QFX 5K platforms, which are shallow buffered platforms based on Broadcom chipsets, the Trident 2, 2+, 3 chipsets. You can use those QFX products in a leaf spine architecture. Or we also have the ACX series of products, the deep-buffered solutions. Like I've seen customers from the media industry, entertainment industry. They need some kind of deep buffers. If you want the leaf and spine and the DCI layers, then ACX could be quite interesting for them. It's also based on the Jericho chipset from Broadcom. And then you have the QFX 10K and PTX product line, which are using the Juniper chipsets, which are deep buffered, modular. You also have fixed options there as well, where you can use them in the leaf, spine, or DCI roles. And then, of course, the MX product portfolio, that I explained to you. If you are looking at, if you have use cases where you're having MPLS, and they will normally say MX is a Swiss Army knife, right? When you really want to do special routing stuff, you can position MX, especially in the DCI and edge kind of roles. And this is one slide that I always like, because it gives you a consolidated overview of the different products that we offer, and also the chipsets that they currently run on. What we're seeing more recently is that the whole industry, customers are moving to Trident 3 based platforms, right? The QFX 5120s, you get it in different form factors, right? With MACsec, and you have with copper ports and with enough 100 gig capacity where you can deploy, the 32C in a spine model. So you can build an leaf spine border leaf roll completely with the QFX 5120 series. Of course, when you are looking at more bigger designs, then we have the QFX 5130, QFX 5700s with the Trident 4 chipsets as well, especially the QFX 5700, which is chassis based, right? It's a slightly bigger box and it comes with different line cards and several form factors that could be interesting for some customer use cases. And then coming to the Tomahawk based products, we have the QFX 5200s, 5210s, and 5220s. Of course, the fundamental difference between the Tomahawk and Trident is, Tomahawk is more power and more ports and capacity, whereas Trident is more feature oriented, right? So that's the kind of difference that you have. And as I told you before, the ACX 7100 is the ACX with the debuffer based on Jericho chipset from Broadcom for debuffer solutions. You could think of building leaf spines with ACX products. And of course, you have the Juniper custom silicon, right? These are the standard QFX 10Ks and the PTX and product lines. And yeah, I recommend you to go through our documentation where we recommend, certain Juniper products on to certain roles. For example, if you are considering a lean spine, you could consider the following QFX products. And what's interesting is, what I have not discussed before is certain EX products, when you're looking at more cost-effective and smaller deployments, because these EX switches also use the same silicon as some of the QFX Broadcom-based chipsets, so you can use them in your leaf spine DC design as well, especially the EX 4300, 4650s, right? And then when it comes to the border leaf functions, right, depending on what kind of DCIs and what kind of extensions. I mean, we discussed, the L2 stretch, L3 stretch, and what kind of DCI you're using. You might have a choice of different products there as well. You can also use an MX, PTX, and things like that. And what I would recommend you is to go to this link, right? I mean, we can share this in the chat as well. If you go to this documentation, this gives you a good idea of, if you're using an CRB model, what are the spine devices, and also it gives you the recommended software release for each platform as well. That can be quite informative when you are looking for devices and looking at what releases to use and so on. So this documentation is part of the Juniper Validated Design Center, right? We have a validated design center, and there you find this. So you can share the link as well. So that's it from my side. And Eric, I hand over the stuff to you. You can take it further.
Okay, thank you, Muto. So I will then share my screen meanwhile. So hang on just a second. And what we have done so far then is we have walked through the different alternatives for architecture as well as the platforms itself. So if you remember then, now we should have like a short break. This is a long session, so I think everybody then just have like a 5-minute break. So if we're back now in 5 minutes from now, we will then kick off and talk about telemetry and how that could be then used by the Paragon platform portfolio. So see you back in 5 minutes from now. Thank you. So slowly, I think we will kick off the second part of this session. So for those of you who had something to drink or an email, whatever, please, we will start again. And as you can see, the next session will very much be around telemetry and Paragon portfolio. So why do we want to do this? Well, let me first switch into this slide. So I do this instead. So as you understand now, with Mutte, what he did in the previous, he discussed different architectures, ERB, CRB, and so forth, and also ways of building DCI, including the platform supporting different use cases. As you remember from the first slide I showed, or the first slides, I would rather say, initially, we are focusing very much around Abstra. And on Thursday, we will look into all those designs and things that Mutte discussed, what is supported by Abstra, because it's just a limited use cases of what was shown previously. But enough about architectures, now about telemetry. So why is that important? Well, as you know, today we're talking, you can say the battle today of networking is moving from speeds and feeds in the past. Now we're talking about lots about automation and making things simpler. And the next thing that will happen is like the next battle will be to understand what is actually happening in our network. Very much like for those of you who have been into the MIST portfolio, where you know, by the feed, the telemetry feed from APs, the switches, and also the SD-WAN is like the key thing in order to understand what is actually happening in my network, and more importantly, what is happening to each and every customer, or in this case, relation to data center could be the applications. So telemetry is and will be even more important moving forward. So this slide, what it tries to illustrate is like, as you can see, Abstra can do telemetry, but only for the fabric itself. As long as you bring in something else outside of the fabric, that could be a firewall, it could be anything else outside, that is not seen and understood by Abstra. So as you know, in a real world scenario for data center, you have, you sure have an IP fabric, but usually you have other things. For instance, you have the SRXs maybe, or firewalls, and it would be nice to know what is actually happening in those or other devices as well. And in data center specifically on the server side, we don't have any visibility within Abstra, but by using Paragon, we can actually know what is happening within our servers or even hypervisors and so forth within a data center and also between data centers, which you will see. So that's the thing, like what you can think about as a partner like the Abstra, you can do, yes, you can build, design, build the fabric, and then you can have some rudimental telemetry. And then on top of that, you could then add Paragon Insight and Paragon Active Assurance, which you will see. And those of you that have been around for some time, you know the Paragon is like the umbrella for lots of platforms or solutions out there. And today we'll be focusing on two ones, which in the bottom of this slide, which is Paragon Insights, which formerly was HealthBot, and then Active Assurance, which is formerly NetRoutes. So those two are the key focus for these sessions. And speaking about the future, I mean, in the past, you know, probably that we have used SNMP, syslog, CLI, and so forth for ages, more or less, which has been working pretty good. The challenge will be then as we're moving into specifically the data center environment, where we're talking 10 gigabits, 25, 100, or 400 gigs. It's too much data, and it's like real-time scenarios we need to detect. And using SNMP, as you know, we cannot detect everything because the sampling period is not good enough. So therefore, telemetry is today where we can do streaming. I'll talk a little bit more on what that means, streaming. What will happen in the future, like we will do even more things, like we do in-band telemetry. And what is that? Well, as you can see here illustrated in the slide, it's like then we add things into the traffic. So if traffic is going from left to right, from a server to another server, we then include things happening along the way. So for each hop, for instance, we could add some telemetry per device, and then in the end, that is sent eventually to the collector that then collects and understands more efficiently what's happening, and then just getting the feedback directly from each and every device. And as you know, Juniper, when it comes to telemetry, we could support almost anything when it comes to type of customer. And that's the power of UNOS. And as you know, what we now have slowly introduced, what was mentioned by Mutu, we also have the EVO, the evolved operating system that we have, for instance, for the QS 5700 and also for the 5130. So even if you're using any of those platforms, you're able then to support from the left, for instance, that you actually feed raw telemetry, you could say, directly into someone. And yes, I have my own tools and teams. I have done my own home-built networks applications that can deal with that. Oh, fine. Usually that's for the big guys. Then in the middle for the B and the C category customers, then they're using usually some kind of open source tools that they build either using some Juniper plugins, or they have also their own tools that they want us to integrate with. That works fine as well. But today we talk more about, I want from a partner or a vendor in this case, I want a full-blown solution that actually comes like a package one that I buy with the software, I get support, I don't have to do development, but I could do. So it's like a semi-open platform, which we will see. And that's where HealthPort, or now it's called Paragon Insight, comes into place. But there's a quick look into what we have done and the difference. I think this is probably well known. I mean, we used to do SNMP for a long time when it comes to telemetry or actually network management. There has some drawbacks, specifically when it comes to detecting like near real-time scenarios. And that's where the push model comes into place, what we call now more telemetry. And this is where you asynchronously from each and every device send information that you have defined to a central collector. And by doing that, we can then, if something is happening in a network device, we immediately send something to the collector, which is then more or less detected in real time, depending on what kind of information you're looking for. And as you know, the telemetry interface we have, which is called JTI, has been around for some years now. It could distribute different information into the collector. So in this case, as you know, sometimes we are interested in what's happening on the interface level, or sometimes you want to know on the control plane what is happening there. So that's different telemetry, and has of course different categories and also different requirements when you push that out to the collector. And speaking about sending out the information, when you look into, if you want to do some close to real-time telemetry, well, there are today 3 versions that we support. And starting from left to right, we have something that we call Juniper native with UNOS, and that is a proprietary, it's built into UNOS itself, and it's efficient and very, very good at detecting like real-time scenarios. With that, we have then on the left, we have 2 standardized using OpenConfig instead of Juniper data model. And these are also very good in detecting almost like real-time scenarios, but they're standard-based. And the good thing about that, as you know, standard-based, we could in theory then support any kind of vendor. Today, we support Cisco to some extent. We could in the future then support other vendors as well, but that is today in the Juniper Paragon Insight. And of course, once again, if you have any questions, please post them in the Q&A and we try to answer them during the session or afterwards. So streaming telemetry, how does that work then? I mean, within our platforms within Juniper, we have different support for streaming information from the device into, in this case, the collector, which is Paragon Insight or formerly HealthPod. And this is on this slide. This is just a few examples of what could be sent, like on the data plane versus on the control plane. If you want to have the details, there's a link down there that you can look into that gives you much better understanding per platform what is actually supported. So the intention from Juniper is to make more and more information available over the JTI interface in Junos, so you can actually stream it like real time to, in this case, for instance, Paragon Insights. And as you know, today we're focused on data center. So that's a small portion, I would say, of all the sensors we support. And what is a sensor then? Well, sensor could be seen like the specific information you want to be sent from that device into the collector. If you look into the left side, the most left column, you see different kinds of categories what we support, and that is like traditional things like interfaces and so forth, all chassis, BGP and so forth. But then in the very end, there's also one row which is related to mostly data centers, EVP and VXLAN. And this is where, for instance, we are specifically using Paragon Insight to detect things which are related to EVP and VXLAN, which cannot be seen and reacted on by Apstra. So that is one big difference. So the Paragon Insight understands, measures, and could react on telemetry based on EVP and VXLAN, which is not currently the case for Apstra. So that's like an add-on thing. So let's say you have then launched a network with Apstra, and you then want, like day two, I want to have a better understanding how is my actually EVP and VXLAN network doing. I can use Apstra once again, but if I want to have a more granular understanding of EVPN, which you will see, then I could add Paragon Insight to that. And I will show you later on what kind of things we add in terms of EVP and VXLAN for Paragon Insight. But before we do that, as you know, the Paragon Insight could support different ways of sending telemetry into the collector itself. So starting from the bottom until the top is like SNMP, that's like the legacy, and CLI as well. But it's good to have that because not all boxes will or have all the streaming capabilities according to some of those listed here at the very top of the slide, like the ATI. Netconf is, as you will see, is also quite often used. Some of the things I will show in the demo are netconf based, and that is very much like you go out and fetch information, which is good enough if it's not like real-time, non-real-time scenarios you're looking for. But as soon as you want to detect things which is very close to, like, for instance, microbursts, I will touch a little bit more on that, then you have to go into like the three topmost ways of distributing data. And this is, as you can see, very close to the data plane and the packet forward engine. And this is depending also on which platform you're using and what is supported. And that, once again, could be looked into the previous slide where we had this link showing what is supported on those specific devices. And that's how and what are supported actually sending the information from the device to the collector. And just to show you what it could look like on, for instance, a Unis-based device. So this is where you set up typical Unis configuration. So in this case, you have like three sections. So first you define where you want to serve, where the telemetry server is, in this case, Paragon Insight. And then you do a profile. And the most important thing here, of course, what kind of format, if you remember from previous slide, I will send, and the transport mechanism, in this case, UDP. And then last but not least, the most important thing is what kind of information do you really want to send to this case, to the collector of Paragon Insight. So this is where you define the resource. And this is very much like you could almost think as of like in a MIB when we talk about SNMP. So this is where you define, this is what I'm looking for, the interface, logical usage. And then I can also add some reg expression. In this case, I only want to have the information sent on specific a group of devices, or sorry, group of interfaces or specific interfaces, and that's it. And then you will start sending telemetry to the Paragon Insight. So that's fairly straightforward. So with that as a background, I will move into more look into what is actually Paragon Insights adding into data center environment. Well, in general, as you know, HealthBot, as it stands here, or Paragon Insights, which is called now, has historically maybe been mostly used in WAN service provider network, but today we focus on data centers. And it adds a lot of value, I would say. It's also on can do some use cases like it visualizes what's happening, of course, but it could detect anomalies, which is something we cannot do with Abstract in the same sense as at least not for EVPN VXLAN. And it's going to also do some automated remediation. And that means like if Paragon Insights finds something anomaly, we could trigger a script and then we end up having this one. So we have like a closed loop automation. So based on from left to right, where you can feed Paragon Insight with different kinds of data into it using traditional SNMP all the way up to JTI interfaces. By using the playbooks and the machine learning built into it when crunching the data, if it finds this is like an anomaly or something else you define, that could trigger either like an email or Slack or something externally, but it could also trigger scripts. So in what we had, if, for instance, in the Paragon Insight, we can trigger a Python script that goes out, for instance, and rewrites something in your network. Sorry. And then by doing that, we have this closed loop automation. I'm not intending to walk through the Paragon Insight in detail, but just like catch up for those who haven't seen this before. So what is this then? Well, this is trying to illustrate all the steps that happens in the background for Paragon Insight in a closed loop automation architecture. So first of all, you have to define what are you interested in. In this case, for the DC, typically looking into how is my EVPN, VXLAN specific parameters like VTAPs, how many routes, how many MACs am I being announced and received and so forth. So that's where you first define, this is what I'm looking for. Secondly, of course, you have to collect. So you have to tell your devices to start sending information into Paragon Insights. And as we discussed, it's several ways supported actually on the ingest layer for the telemetry data. All that data then is collected into time series database. So this is where we collect everything, and then we start doing the crunching. So the rule engine is based then, of course, of the playbooks you define. This is what I'm interested in, and the rules then start crunching the data you have received in your database, and based on what is found, of course, you can visualize it, which we will see in the demo, showing red, green, and so forth, and even graphs that could be exported. But in a closed loop scenario, then you can also send notification on email and webhook or Slack, which is good. But the most advanced thing is, of course, you can act. So in this case, let's say you find something that the box is not doing well or behaving in a strange way, you could then trigger a Python script that actually goes out maybe and tells that specific device to either shut down an interface or introduce a route or whatever in order to do the closed loop automation. Okay. And if you look into more DC use cases for Paragon Insight, this is where we have I have just listed a few, but I mean, typically we look into the underlying monitoring. So here you could look into by using real-time telemetry, for instance, microburst detection. which is very hard to detect when you, for instance, use an SNMP. I would say it will never happen. So that's one thing. I have a more slide on that later on specifically on microburst. Maybe the most common so far has been looking into further understanding how is actually my VXLAN doing within my data center or between my data centers. So here we can see things like in terms of how is my VTAPs doing, how many routes, how many MACs are being announced and received and so forth. And most importantly, there is some machine learning inbuilt into it. So the Paragon Insight adjusts to, if you slowly grow your network by adding hosts or so forth, you will not get a Paragon indicating there's something wrong. Now I see more routes. Actually, it's learning over time by using machine learning. This is a new normal state that it learns over 7 days. We'll look into that further on. Then we have two quite new things, the VMware vCenter integration and S-Flow integration. And VMware then, that's where we can have some limited look into how it's actually the VMs connected into the leaves. So in some cases, this could be valuable information. Unfortunately, in the setup we have, we don't have that to show. And that also goes for the S-Flow. So one way you could do that is like, for instance, you could start exporting S-Flow information from your QFXs and see if you see anomalies when it comes to maybe if all of a sudden two servers start speaking to each other, which is not the normal state. That could be an indication something is going on, maybe a security thing or so forth. And that's one way of using S-Flow. And all these use cases are then summarized in something we call playbooks. I will show you later on what a playbook is, but this is just to show you a short description of some of the few playbooks which are included in the platform itself. Those are listed in green here. And then we have something I mentioned. This is like a semi-open platform. And that means that you could add your own playbooks and rules, which is each playbook contains multiple rules. You will see that in the demo. So we have a community around this where you as a partner or customers could use the built-in, which are listed here in green, or build your own rules or playbooks. So as you will see then, all these are listed on GitHub. So you will find the Juniper standard playbooks and rules, but also those who are then added by the community. Could be partners, it could be customers and so forth. By that, I think we're getting close to a demo. But before I do the demo and show that, just to give you just a few steps to show it's quite easy to get this up and running. As you will see then in the demo, to have like in QFX or similar up and running in Paragon Insights and then adding a playbook is quite easy. So these are the only steps you do. So first, discover device. I will do that later, yes, shortly. By adding your IP address and a name you can give it. And then sometimes maybe credentials in order for Paragon Insight to get access to the device. And then it gets to part of Paragon Insight and you can enable the next one then, which is like organize your device into device group. And that is just by design, because Paragon Insights needs to group devices into device groups in order to do step 3, which is what kind of playbooks do you want to apply? During this demo, I will focus on EVPN VXLAN, but of course there are different, much more playbooks you could enable if you want, and giving, for instance, information about how is my chassis doing, how is my BGP doing, how is other things doing on that specific box. And once you've done that, last but not least, then you will start seeing things monitoring, and you can have graphs that you can see in the platform itself, or could be then sent over to, for instance, to Grafana, which is quite popular in some network operating center. Also, quite important to understand, like there are some things within Paragon Insight, which is good to know. The playbook, which is like typically a name just which include multiple rules. So rules is actually where you consume and digest the data you have collected if you remember, in the time database. So first you apply a playbook on a device, but underneath that, in every playbook, you have maybe, in this case, 30 rules that crunches the data based on the other fields here, sensor field and trigger function. So those are things that are built into each and every rules, which you will see then later on in the demo. And these playbooks then, what do they actually contain? Well, as you will see, there are some specific ones which are related to EVP and VXLAN. Those are listed here. Those are for spine and leaves. We have for the leaves, we have some more rules, which you will see later on. Well, which is in an ERB's design makes sense, because then we look into VTAPs, we look into announced routes and MAC addresses and so forth. And then we have also a way of doing the ping between the IRBs within a VRF. So this is also good indication that you can enable on devices to verify I have connectivity between VRFs within my EVP and VXLAN. And all of these rules above are actually netconf based. So these are not, if you remember from the previous slides, like JTI enabled. But that's good enough, because this is typically not real-time data we're looking for. So we're using netconf, meaning we're using SSH, logging into a device, fetching the information, and then showing it in Paragon Insight. And looking more into what is actually within these playbooks then, well, this is typically, as I said, within each playbook, you have like 30 or 35 rules. And each and every of these rules do one or multiple things. And the rules in here are doing things like verifying the BGP or EVPN, the BFD, VTAP, IRB, and so forth. So lots of those things you will see are in each and every playbook, which are then containing multiple rules. And if you go further into the playbook itself, EVPN KPI, which is the name of one of the playbooks, these are things we're looking into. I mean, how is the spanning tree doing? How's the VPN and so forth, and BPDU error and so forth. Compare that to what kind of thresholds we have. As you will see, once we launch playbook for a device group, which contains multiple devices, we can then start measuring like static things, static thresholds with which you can set. There are some default values, but we can change them if we want. And we start measuring that. More importantly, we have also dynamic thresholds. So we have, these are the machine learning part, which we will see in the rules. So here we are adjusting where we have the Paragon Insight could up to maybe like 7 days learning what is like a normal state when it comes to how many routes are advertised or received, or how many MAC addresses and so forth. And then we then consider this is like a normal state. If we go then like 3 sigma above or below, that's pretty aggressive. It's, as you know, this is like a 3 standard deviations from the median value. Then we can trigger an alarm. And the good thing about this, once again, it's dynamic. I will show you later on how that is actually within each and every rule. Something which I think is also a very neat feature. This is very hard to demonstrate because it's like regarding to microburst. So this is in the rare case where you might have something that is called microburst. And what is that? Well, you know, this is like a typical old scenario where you have too much traffic coming into an interface and you dropped. And that could eventually affect the application. And this is very hard to detect. But by using telemetry and by using Paragon Insight, we could then detect the microburst by enabling this specific playbook, which is actually built into Paragon Insight. So if you go to YouTube and search for microburst in Juniper and HealthBot, you will find this good video actually showing this. It's a very good use case. and doing this in real time, so to say. But the microburst is just one of the playbooks. If you go into GitHub, I will show you shortly, you will find all the rules and, most importantly, the playbooks as well. So that's a good list and good link for information, but you can also just go to GitHub, search for HealthBot and Juniper, you will find this as well. And on GitHub, as I said, there are Juniper officials and they're also from the community. And Juniper officials is only for Juniper employees, meaning engineers who are adding this. But once again, you as a partner, you could do your own playbooks and rules based on specific requirements maybe that your customer has. So with that, I think it's time to move over to a short demo, unless there are any questions. I don't see any questions, so I will then switch over to my demo. And now hopefully you see my browser. And as you can see, this is like a very small spine leaf network in JCL, actually in VLabs. So anyone that just signs up, customer or partner, can use this as I'm using right now. And in fact, this setup will be used on Thursday when we talk about Abstract, which is also here, as you can see, included. But today we're looking more into the HealthBot. So what does it look like? Yeah, I have already the HealthBot here enabled. So this is typically the dashboard you can start with. And as you remember from what I just showed you, we had actually 2 leaf and 2 spines. Right now we have 3 devices, and the devices are spine and leaf. And I have 1 playbook enabled. We will look into that further on, EVPN baseline KPIs. But now I just want to add a new device. If you remember how easy it is to actually get 1 more device in. So now I will enable to add the leaf 1 device. Oh, sorry, should be 1. And then all I need to do then is just add the IP address of that specific device. And I happen to know this is the 203, yeah. I will directly add it to the device group DC Fabric. In this case, it's a Juniper device. As you can see, it could have been a Cisco. I need to, in this case, also give it some authentication. I'm just using traditional credential this time. So JCL user, this is like standard base, you know, passwords. And then I do save and deploy. And soon this new device then will be seen and start being managed by Paragon Insight. As you can see now, it's being gray, so it takes some time, but as you can also just see, it has picked up. It's a Unix device, as a password. It belongs to 1 device group, which is the DC Fabric one. So if we go back to the dashboard now, we can now see 4 devices. Soon it will be red here as well. Red, by the way, is probably not very good, but the reason for that, as you understand, I don't have any traffic running in here and don't have any very good, like a real case scenario, but to show you how it works. So therefore soon this will be red. So this gives you an indication something is going on there. So if you want to look into further what is actually happening into my DC then. So in this case then I just select a device. I will go and actually use my device group, in this case all devices. And for some reason now the leaf one has not been fully updated, but it will be. It takes some time. I do refresh, maybe then I will see some more. It takes some time, but here you can see things like interface statistics, and this comes from the rules that is a part of the playbooks once again. Here we have specifically on the VPN, it says now everything is green. And if you do mouse over, it shows, well, 0, 0, 0, because right now I'm not actually announcing any routes whatsoever within the fabric. And the BFD here now, the reason why we don't see anything here is because I haven't configured that yet within the fabric. So it's like, it's not like a real case scenario where you have a network up and running, but it just gives you at least an indication of what is happening within this thing. So this is like, now I have only one playbook enabled. And what is a playbook then? Well, built into the platform, we have like more than 60 different playbooks. And as you maybe, if I make this a little bit bigger, you can see here we have things which is not directly related to DC, OSPF, DHCP server, blah, blah, blah. So once again, as you probably know, the Paragon Insight could be used for multiple use cases. In this case, we're focusing very much on data centers. So in that case, just for that, look into what are the EVPN related playbooks that are the default ones into the product. So these are the ones. So if you remember, we have vCenter. So this is VMware related playbooks, which I cannot enable due to the circumstance we don't have any vCenter in this specific JCL setup. But the other ones we can use. The green star here, as we will look into further on, requires advanced licensing. So this is a part of the business model. So there are actually a freemium model and there's a paid version. And in order to run these with green stars, you need actually a real license. And in this case, you can see here, if we look into the KPI here, that is enabled on the DC fabric, that's 4 devices, is up and running. I could pause it here if I want, or I could enable more of the, in this case, I could do this one. I go to the EVPN VXLAN leaf. And as you can see here, which we'll look into further on, here we have like 30 plus rules. So it's EVPN related stuff mostly. And this is where actually the crunching of the data will do. So we'll look into that just soon. So I just want to show you how easy it is to deploy. I have to give it, no, I don't have to give it a name. Yeah, I did, sorry. So what I need to do then, here, I have to, first of all, which devices do I want to run it on? In this case, I should be able to, I do it on leaf 1 maybe only. And as you can see here, for instance, I go into talking about, we have some static values we can change. So here, for instance, here we have like VTAP traffic, and these are the things, these are default ones, but of course you can change it to any value you want. That was a little bit too low. Sorry. Or in this case, I can do like whatever I want. And then I can run this. And now I'm running that specific playbook. I will do this again. No, yeah, I have to write that again, sorry. And soon, sorry. AVPN. The leaf one, for some reason, didn't start. Okay. Okay, never mind. But the key thing then is like, it's quite easy to enable this, and then you start monitoring. And what exactly are you into? Well, as you saw here, we have the rules. And these are also listed on GitHub, we will look into soon. But the rules could also be viewed here if you want. So here we could, all those rules you saw within the playbooks are listed here. In this case, I can then search for, once again, EVPN rules. And here we have, for instance, checking how many prefix are being announced in EVPN. So this is a rule. I have different fields here. So what it does here is collects EVPN routes that are being announced and notifies anomaly when advertised route count exceed thresholds. And the good thing here, we have a static threshold, but also we have this dynamic, that is the machine learning part into it. So this is where you define things, fields, vectors. Usually you don't have to change this. This is just if you want. These are the default ones, which works pretty good. But of course you can change it if you want different ways of doing this. But if you want to look into how it looks like on the GitHub side, so if you go into GitHub, search for health code rules, you will find this. And once again, here you can see the official here listed and the community. So Juniper official are the ones I just shown. And the ones I just showed, solution was actually the EVPN VXLAN stuff. Well, we will shortly look into that. And in here, we have YAML files and we have some rules, which are these ones. And we have also the playbooks, for instance. This is, if you remember, this is the way we can do ping more or less, where you're checking the connectivity between IRBs within a BRF. But let's see, for instance, we pick a specific rule. And if you remember, playbook in this case could be like 30, 35 rules. So this one specific rule. So what does this do then? Well, detects the neighbor, the BGP neighbor advertised routes and verifies those towards like static routes or static thresholds, as well as anomalies where we have these dynamic thresholds, that is machine learning. So first of all, this is where we have the machine learning. And this is, once again, the algorithm we're using here is 3 sigma, which means like after measuring the learning period, so 7 days, we start measuring 1 hour buckets, which means like each and every hour we have a bucket where we measure how many routes have we received, advertised during this hour, every hour during 24 hours. So we have 24 buckets. And then we do that for 7 days, so 7 times 24 buckets. And then we learn this is the normal state for our network. So after those 7 days, if we go out like 3 sigmas outside of those learned dynamic thresholds, we then consider that anomaly, and that will be announced within HealthBot, and we should or could or maybe not take an action based on that. So that's what it looks like. And just briefly, if you saw, going back to the HealthBot rules, on the community, so this could be anyone that adds anything. In this case, EVPN, someone has done things here that anyone can use, rules or even playbooks here. So this is where you as a partner are welcome to add if you want, but of course you can use the built-in one if you want only. Okay, so that was like an overview of the HealthBot then. So going back to the dashboard again. Okay, so now my leaf is good. The other ones are bad, okay. But what could I do then when it comes to announcing something external from HealthBot? Of course, you could look into dashboard, but there's also ways of monitoring it externally. We can do graphs. So for instance, here, as you can see, I have done one graph, which is based on Grafana. And this is like just checking in traffic, input bytes on a specific device, in this case, Spine2. And the good thing about this is, like, as you saw, this is Grafana based. So what you could do then, all these graphs you could build here on your own could actually be exported to external Grafana. So that is quite nice. And when it comes to notification, for instance, so here is where you could then just give it a name. We can get a description of different webhook, Slack, Kafka, Teams, or emails, and you can send reports or whatever you want externally as well. Okay, any questions on Paragon Insights before I move forward? I don't see that. And just to show you, the last slide I have on HealthBot, or in this case should be Paragon Insights. So what we could do then is actually, first of all, of course, using the playbooks from GitHub. So if you have your own, if you build your own, to insert that into HealthBot. And if you want also, you can have Netbox sending asset data into the HealthBot. So there's a lot of APIs into it. And then within HealthBot, of course, typically what is known for is like monitoring, visualization, what's happening. And that could be sent to like an external Grafana, like a networking operator center. Or it could be actually, which is probably not well known, that we are using this also in the session next week. Hopefully, if everything will show a demo where if we're using Netbox, which is like an IPAM, open source IPAM, which is on your right here in the picture. Let's see if you insert a new IP address on a specific interface, that information could be sent from your IPAM, in this case Netbox, to HealthBot, that triggers a script that goes out and add that specific IP address to that specific interface in your fabric. So HealthBot could also be used actually to configure things in your fabric, which is not well known, I think. Anyway, let's do the thing. What about licensing? Yeah, well, for HealthBot here, it says, well, it should be Paragon Insight. There are 3 versions of licenses. There's one free version and 2 that you pay for. We start with the paid one. It's like they're very similar. What is different is like you can have a database high availability, so you can have the information you collect from your devices. You could have then multiple databases for redundancy. That is typically the difference. If we then compare for the free version, which then might sound very interesting, yes, it is. It's like it's free for use. Anyone can use it, but it's, as it says, it's limited, and it's limited in terms of how many playbooks and what kind of playbooks you can use. For instance, if you remember from the demo, those EVPN-based playbooks are not being able to use with the free version. So if you think about that, maybe we should look into doing the advanced or premium if you want to do like a good POC or whatever, and the freemium might be used just for showing things, but in real life for data center, it's not very useful, to be honest. And then we have some pretty nice things, I think, for the future. So if you look in the very bottom of this slide, you have some robot things, which is like very similar to what we did, like for those who know about ServiceNow, which was like a service we had where we collect things from the devices, and we can also proactively feed into the network bugs, KBs, end of life, and so forth, and have the Paragon Insight react on those. And the most advanced thing at the very bottom, advanced cross correlation, that could be, for instance, in a data center, if we see that all of a sudden we see different traffic patterns happening between maybe multiple data centers. If you have that, that could be triggered, that this is cross correlation and predict. This is still roadmap, is still not implemented. Further on the licensing part, then this is very much like you have a base license, and then depending on what kind of device you attach to it, there's a specific feature name. So for most of the cases we're doing, we have this, which is here listed as C2, So that's where we have almost all the QFXs, which are non-chassis based. And that goes for the ACX as well. So that's where the majority, by maybe 95 or 98% of the licenses. So you just pick how many devices, and then you get the license you want to use. And once again, speaking about the freemium version here, so you can see here, those listed on the right in you could say pink, maybe the color is. That's what you can use with the freemium version. So it's a limited part of, once again, the VPN playbooks. Oh, sorry, the playbooks in general you can use. And in order to run HealthBot, you need a server. And in order to do the sizing for that one, there is a tool you can find on our homepage. And that's where you, on the left then, define what kind of playbooks you want to run. And then how many devices of different kind of devices, and also how many devices. And then after entering that, then you get like the output, then what kind of a server you need in order to run HealthBot for that specific setup. Okay, any questions on HealthBot? Sorry, Paragon Insights it should be. I don't see that. So we continue with the last part, which is Paragon Active Assurance. So what is this? Well, former is NetRounds. That was an acquisition we did like last year. And once again, just to make sure you understand, where does it fit into a data center environment? Well, this is like an add-on assurance part you can do if you want to address, if customers asking for, I want to know, for instance, how is the traffic doing between my data centers, or how is my virtual machines doing, my host and so forth, which you cannot do with Apstra or Paragon Insight. Historically, Paragon Active Assurance mostly have been used with the service provider environment, where you do like, once you have enabled a new service, you can then have these test agents here, you can see, which you place out in the network, either as a virtual machine or container, somewhere in the network, and then you start sending synthetic traffic. So by doing that, you can then test, is my network, or my service rather, working as expected. In an overview of this, just to understand what are the Paragon Active Assurance. Well, it contains of two parts, you could say. First of all, of course, you need some test agents. So those could be run like VM and containers. If we have an Evo-based platform, these could be run on those platforms like a QFX 5700 or a 5130. If you do not have that, then it could be run on a virtual machine or as a container. Or it could be in sometimes, if you want, even on an NFX. And then on top of that, of course, you need some kind of control center. Although this is where you typically then from a GUI could set up what kind of test you want to perform between the test agents within or between your data centers. And of course, everything of this could be automated. So there you have then on your upper left, you have all kinds of APIs. You can use REST APIs, Netconf and Yang, to talk to the Paragon Active Assurance to set it up as an orchestrator. And then, of course, the output could be reports, or it could be integrated with other systems. I have another slide in the end. So it's very open, once again, for using external orchestration or external presentation applications. And what could you do then? Well, as I said, you can do anything between layer 2 to layer 7. So as you can see here, it's very much on focus on maybe some service provider use cases such as IPTV or over-the-top video and voice and so forth. But of course, you can test, as I have the next case, either layer 2, how your network is doing, or layer 2. And one typical scenario, this is what we did for one customer, is like they had multiple data centers, and they had networking infrastructures between the data centers were not owned by themselves, and they had some problems with that. And In order to find out where the problems actually were, they installed the test agents in each and every data center. And then they start sending traffic, test traffic between the sites, and to see, where do they actually find, where is the problem? And this is one way of doing it. This is between data centers. We could actually have other use cases where we're looking within the data center. So if the first use case was between the data centers, we could do it, for instance, between racks or rows within the data center, like in the use case 2, where you then place test agents per row, for instance. And then in use case 4, you can have it within a host. So in a virtual machine, for instance, a test agent, and then you can test all the way down to the router or the gateway, or you can test it to the physical NIC, or even to the hypervisor or the layer 2. So that's a very good way of having to understand all the way from your host, your VMs, layer 2 or layer 3, what is working or what is not working within your data center. Last case, use case 3 is maybe where you have a VNF. That's typically maybe for a service provider, maybe where you can try a service you have between different virtual network functions. And of course, there are different ways of running this. Some customers prefer to run it like a standalone. So it's like they're using the built-in graphic user interface, and they have the test agents, and that's fine. For maybe larger organizations, or where they have some other existing system, maybe they use some other orchestration tools. I mean, maybe Ansible to talk directly into Paragon. And instead of using the graphic user interface to present or run reports, we can then distribute the information to external system performance management tools, OSS, and so forth. So it's very, once again, very versatile in that sense when it comes to integration externally. But what's included then when it comes to buying this stuff? Well, actually, there are 3 different tiers of functionality. So on your right, you have standard, advanced, and premium. And as you can see, standard is typically you have some layer 3 features you can do, quite basic, very much about checking the layer 3 connectivity, which might be fine for maybe the first use case for data center. If you want to do layer 2, then you need actually the premium one, which is here listed as Ethernet service activation. So we need a different software version of that one. So this is one where they have 2 versions actually within Paragon. You have the Nano and you have the Mega. And the Nano is like typically for layer 3 things only. And the difference is like scalability and also functionality, of course, according to the previous slide. If you want to do more layer 2 things, then you will need the Mega one, which could be on-prem, but also could be a SaaS-based, meaning somewhere in the cloud. And here we talk about layer 2 and layer 3. So here we can do everything listed when it comes to. But as you can see in the very bottom, you have some indication of pricing. So the pricing goes up quite radically when you go into the Mega. But for those customers who are interested to have full understanding all the way between data centers, they want to know how the hosts are doing and even the VMs are doing, that might be an option. Because as you can see, for instance, in the Mega, there's no limitation on number of SKUs, number of test agents, sorry. So once you've done that, that works pretty good. And as the last slide then, I will just show you. So if you want to get together a bill of material, so first of all, you have to choose, do you want SaaS, cloud, or on-prem? If you need an on-prem, you have to go to Mega. Then you have a software SKU. And what you do then, you then have another SKU, and that is how many streams. And streams, like typically you do like maybe full mesh. So each test agent and then speaks to each test agent. So like if you have 10 test agents, that's like 10 times 9 times 2, that's 45 SKUs, stream SKUs. And then you have a boom. And for the Nano one, then you have also to include how many test days. So it's quite easy. So in the end, then you have either 3 SKUs or 2 SKUs in order to put together a bill of material. I understand that was quite quick in the end. So we're close to the end of the session. Are there any questions? No, I cannot see that. If no further questions, I will just ask you if you have any questions and so forth, please feel free to reach out to me or Muttu. Otherwise, I will hand over to you then, Sarah, to finish this webinar.
Okay, great. Thank you very much, Eric, and thanks, Muttu. And thank you everyone for attending today. This brings our session to a close. We wish you a pleasant afternoon. Thank you very much.